In this video, we're going to talk about how to graph an ordered pair on a coordinate plane. Before we get into that, let's talk about the anatomy of a coordinate plane first. A coordinate plane is made up of two axes, or two number lines. The first being your horizontal axis, and the second being your vertical axis. Please note that you may know these as the x-axis and the y-axis respectively, and I've gone ahead and I've highlighted them on the coordinate plane for you. The point where these two axes intersect is called the origin. This is also known as the point 0, 0. In other words, our axes are going to cross where 0 appears on both of their number lines. Note that the origin will separate the number lines in a positive number group and a negative number group. The other thing that I want to point out is that not every coordinate plane will look the same from problem to problem or from situation to situation that you are studying. So in this example, the scale, in other words, how the numbers are being counted on the number lines or the axes, has a scale of 1. Notice that we're going from 1 to 2 to 3 to 4 and so on. So this is just one example of a scale. For example, we could have our scale counting by 2s on both the horizontal and the vertical axes, as we can see on the image on the left. And the scales do not have to match between the two axes. So, for example, the one that you see on the right, I have the horizontal axis working with a scale of 5, and the vertical axis is working with a scale of 3. But do notice that everything does remain balanced. So, for example, with our example on the right, if I'm going to count by 5s on the right side of the origin, I'm also going to count by 5s on the left side of the origin. Now that we have a better understanding of the coordinate plane, we're going to go ahead and actually graph an ordered pair. We also might call this a coordinate point. For example, we'll work with the point 3, 4. So just like its name, there is a particular order that these numbers are going in. So for example, 3 is going to be a number located on the horizontal axis. And the number 4 is going to be located on the vertical axis. So what we will do first is locate the 3 on the horizontal axis. I'm going to use this dotted line to indicate where the 3 is located on the horizontal axis. I'm going to also do the same thing for the 4 on the vertical axis, like so. Where I see these two dotted lines intersect or touch one another is where the point 3, 4 is located. There is another way that we can approach graphing a coordinate point. Let me start off with a fresh screen. Imagine that you're starting at the origin, or the point 0, 0. If we go and look at the ordered pair that we have here, we can kind of look at the sign of the number and also talk about direction. So, for example, since the 3 is located on the horizontal axis, this means I'm going to go to the right 3 units. For the 4, since it's going to be located on the vertical axis, this tells me that I'm going to go up 4 units. So another way of doing this would be starting at the origin. So I'm just going to kind of map my steps here. I'm going to go to the right 3 units, and then from this point I'm going to go up 4 units. And as you can see previously, we arrive at the exact same coordinate point. For this example, imagine that you're starting at the origin point, or 0, 0. Now looking at the ordered pair that we've been provided, take a look at the signs of each of those numbers, and again, remember which one is going to be located on the horizontal axis and which one is going to be located on the vertical axis. So for example, looking at the 3, we're basically saying, starting from the origin, we're going to go to the right 3 units. And we're going to the right because to the right of the origin is where our positive numbers are located on the horizontal axis. Likewise, for the positive 4 that we see on the vertical axis, this is going to tell us to go up 4 units. So how does this look visually? Well, if we start at the origin, we're going to go to the right 3 units, and then from there we're going to go up 4 units. And as you can see, it takes us back to the same location that we had arrived at from our previous attempt. The other thing to note is usually when we're graphing coordinate points, we don't include kind of the trail that we've blazed here. So really the only thing that we want to see is just the coordinate point 4, 3, 4. Let's go ahead and take a look at another example. So let's look at the ordered pair -6, -1. So again, one way that we could do this would be to kind of sketch out those dotted lines and look for that point of intersection. In doing so, we can see that our coordinate point is going to be located here for -6, -1. If the dotted line method doesn't work, remember you can also talk about this as if you were journeying or walking from the origin point to that desired location. So if we're looking at a -6, this tells me to go to the left 6 units. So the negative is what is telling me to go to the left. And the -1, since that is in the vertical axis position, this is telling me to go down 1 unit. Likewise, if we do that on the coordinate plane, again, starting at the origin, I'm going to go to the left 6 units, and then I'm going to go down 1 unit. And again, I arrive at that coordinate point. And best practice does say, don't necessarily include that path on the coordinate plane, just include the coordinate point. Let's look at one more. Say we are working with the point 0, 8. Again, the first method, laying down those dotted lines and looking for the intersection, would look like this. The value of 0 on the horizontal axis ends up overlapping with the vertical axis, so this is why my light blue dotted line is laying right on top of that vertical axis. But as we can see here, our coordinate point of 0, 8 will be located right here, so on the 8th unit on the vertical axis. Again, we can take a look at this using more of that directional approach. So a value of 0 in the horizontal position is really saying you're not going to move anywhere. So I'm not moving left, I'm not moving right, I'm just staying put. An 8, however, in the vertical position is going to say that we are going to go up 8 units. So what this will look like starting from the origin, again, I'm not moving left or right, so I'm staying put, and then I don't move until I'm told to go up 8 units. And again, we arrive at our coordinate point. And as always, best practice says, don't show the pathway. All right, let's go ahead and have you try some on your own. What I would like you to go ahead and do is take a moment and try to graph these 4 coordinate points. You might want to go ahead and actually label A, B, C, and D next to those coordinate points when you're done. When you are ready, go ahead and press play for the video, and we will review them together. All right, so I'm going to give you a moment, press pause, and try these out. Okay, here are your solutions. So I'm just going to describe these using our directional method. So for -3, 6, it's telling me to go 3 units to the left and 6 units up. For coordinate point B, or ordered pair B, we are told to go 7 units to the right and 4 units down. For coordinate point C, we are told to just go 9 units to the left, but we are not told to go up or down. We're told to stay put because we have that 0 value there. And then for coordinate point D, we are told to go 5 units to the right and 10 units up. So in this case, notice I didn't have a clearly labeled 10, but Because we are working with a scale of 1, we know that the next value above, or where that arrowhead is on the vertical axis or the y-axis, would be 10. So that's why my point is all the way on the edge. All right. This completes this video.